Hello and welcome everybody. We are very happy to have Manika here. She's doctor and from the University of Delhi. She is also chair of professional development subcommittee at IFLASTL, and she has a very great book titled Text Mining for Information Professionals. And we have here, and you can follow her on Twitter. Also, don't forget to follow us at Arldiz Umia. We can have you and for our next event. Okay, now stage is yours, Manika. Let's start.
Thank you so much, Nazreen and Yalda, for giving me this opportunity to talk to you over here. So a little bit about me. I'm a fourth-year PhD candidate in information sciences at University of Delhi, India. My research focuses on information retrieval, digital libraries, social informatics, and scholarly communication using text mining, NLP, and machine learning techniques. I have worked extensively with textual data, and as Nazreen has said, you can know more about me on my website, and I'll be happy to connect with you on Twitter. So as also Nazreen has covered that my book has been recently online, and these are the chapters which are in the book. So I will encourage you to go to the the GitHub account of the book. So over here, I will encourage you to go to the curated data set. I have compiled all the open source data sets which are available for text mining, which can you use for practicing or even for teaching. And then I have also prepared a website for the book. So over here, you can know about the book, the author. This is me and my supervisor, PhD supervisor. We have co-authored this book. Then there's a section of stories where we have made an open form for the librarians and the professionals to share their stories and experience how they have used the text mining techniques in their research. So this is a very interesting section. Sadly, I wasn't able to include the whole story on the website due to the copyright issues, but at least you will get the gist, which are the stories has been covered and the authors and how to connect with them, their Twitter account is there or other links they have shared with us. And also the book has case studies. These are the hex stickers made by me. You are welcome to use them. And here you can go and maybe download the whole code and the data. And even you don't know R, you can just click on this R Studio server. It will open in cloud for you, the R server, and you can test out and maybe use your own data to test out the code. Just give me a second. You can see the screen, right?
Yes,
yes.
So let's start with the topic. What is topic modeling? A topic can be defined as the main idea which is discussed in a text. So whereas topic modeling is the act of text mining approach to understand, organize, process, extract, manage, and summarize knowledge. Right now, there are no machine readable annotation that can tell that text modeling program about the semantic meaning of the words in the text. Thus, it infers the abstract topics based on the similar patterns of the words used in the text document. Or in other words, you can say that topics are the similar group of words from the collection of documents that represent the information in the collection in the best way. So when should you use topic modeling? Is when you have very vast collection of data and you don't have you need so much energy and time and human efforts to go through it manually. Second, when the collection belongs to a specific subject, such as if the collection is related to agriculture or economics. And third, when the collection has similar type of documents, such as all the documents are tweets or all the documents are newspaper articles. So when not to use topic modeling is when you relatively have small number of documents, when you don't know any idea about your collection. So in that case, it's better to use clustering. And also when there's mixture of documents, like you have tweets, also you have research articles, also you have newspaper articles. And in that case also, it's better to use clustering instead of topic modeling. So topic modeling uses the bag of word technique where it treats each term as a single token of a sentence, and the terms type and for documents and ignores it. Now I will just explain a little bit about the main concepts which are important. So bear with me. So first is like term document matrix. It represents the terms as a table or matrix of number for a given corpus. The terms are represented as rows and the document as the columns. And the occurrence of the number of term and documents is entering the terms in the boxes. Second is the document term matrix. This is transposition of the term document matrix, where each document is now in the row and the each word is in the column and the number of occurrence is in the boxes. The next is the term frequency inverse document frequency, TF-ITF. It evaluates the relevancy of a term for a document in a corpus and is the most popular weighing scheme in information retrieval. It increases with the number of occurrences and rarity of a term within the corpus, where terms with higher TF-ITF values imply a stronger association with the document they appear in. From an information retrieval perspective, when such terms are used as a query by a user, this is the de facto method for comparing performances in text mining and information retrieval applications and gives better recall and precision values than other weighted schemes. So these are just the concept I have explained. And now how topic modeling works is that it ingest some of the documents and then spits out the words with some percentage of like each document is then consists of some proportion, like how the topics were there. But these labels are given by humans, and the algorithm is not that how would you say, intelligent enough to label the topic. They just give you the words, and as a subject expert in your field, you have to label them. So the document, it will give like this document consists of 100% of this topic, or it consists of 60% of topic 1 and 40% of the second topic. And you can see that each topic consists of the words over here. So the topics consist of different words, and you will get a percentage of this topic because this document consists of how much percent of the topic. So there are some popular packages in R to perform topic modeling. But today we will use 2 of them. So what is the main procedure of doing topic modeling? Is first you obtain some data set, either via web scraping or API, or you manually get it. Then you prepare the corpus, do pre-processing, that is removal of stop words, tokenization, stemming. Then you do exploratory data analysis, where you make word cloud and clustering. Then the main step is to determine the number of topics. There are a few matrices like coherence, perplexity, or entropy, but it is most of the analysts suggest that they don't give that much of idea. They just give you a vague idea of like this in between this number of topics you should use. But at the end, it's only the analysts, like they have to do the hit and trial method and test out different number of topics to see how many number of topics are fitting best to their corpus. Then next is to select the appropriate algorithm. There are so many algorithms to do topic modeling, such as latent rate allocation, structured topic modeling, and others. So you have to find which one you want to do. Then finally is to repeat the process again and again so that the algorithm fits best to your corpus and get good results. So today I'll be using a dataset which consists of 2,500 research abstracts from 6 years of publication by University of North Carolina. at Charlotte, and which has the social science department, from social science department, computing informatics. Let me show you how the dataset looks. So it has like article type, abstract. We will do topic modeling on the abstracts. And then we have a column on college and department and year. Can you see my screen? And also I have shared the repository from where you can get the slides and this IMD code. Let me share it again. Yeah. So these are the 3 research questions which we will see. First is what are topics? So I'll be using 3 scripts with 3 different algorithm for topic modeling. First is data interactive allocation. Second is correlated topic modeling and model, and then structured topic modeling. CTM and STM are both the from STM package, and LDA is from your Tidyverse package. So first we will see what are the topics in our corpuses. So first we will load the libraries, Quantdata, Tidyverse. This is for word cloud and Quantdata text plot, and get our data set from the GitHub repository and see our corpus. Okay, so now our corpus is created. Then we will determine the document feature metrics and remove the stop words. And also we will also remove this sparse term, that the terms which have occurred like gives us 0 occur like in some documents and not, and they create some nonsense. So using this trim function, we will remove it. So in the document term measure, we will use the corpus which is prepared, and then we will remove the stop words from English and use the n-grams, like 1 length, 1 words, and we will not stem the words and remove the numbers, remove the punctuations from the abstracts, and then remove the symbols. And also we will remove the words which are used less than 10 in the 10 times in the document, and then we will remove the words which are occurred less than in the 5 documents. So now just let's explore the 50 words in our corpus. So these are the 50 words which are most used, like use, study, result, model, data, effect, can, research. So because the words are still occurring, we will in the next, I will show you later that we will use our own list of stop words, which we will remove. Because right now we're just at the exploratory data analysis stage, so we will just let it go, and we will recognize such words which are nonsense and we want to remove later. So now just visualize this our data in word cloud. So again, the frequency, the words which are coming as a table overhead data frame, we are just visualizing that in the word cloud. And now we will create a dendrogram, like how the words are associated with each other. So we can see it's not that clear, but maybe you can see that these are occurring together, use and model are together. So like this, you can see that some of the words are occurring together, so they are associated with each other. And then now we will do topic modeling using the topic model package. And here we will use the GIF sampling, and and we will use the iteration 500. For now, we will use, this is the case, the number of topics we were choosing. So because I have already done this course, I know that it fits best for 20, but you can try with, default value is 10. So you should always try for 10, but depending on your corpus, should know if you have more number of data, you should increase this number and test out different numbers to see where it is fitting best. Then this is, okay, so here we will convert the data frame to topic model package. Then we will use LDA, where we will use the LDA algorithm. The topic of the number of topics is here, the method escapes. And then this is just for repetition that we can, because this is a probability based algorithm. So whenever you run it, it will give you different results. So if you have the seed value, so you will get the same value again and again. And then we will do the iteration, like it will go run like 500 times, so it fits our model better. It will take some like few minutes. Now, so it's ready. Now we can visualize these results. There is a similar thing of algebras in Python, so it is used over here. So first we have to convert this into that function. So I have used this function for visualization. So it will open a new browser where you can visualize the results of LDA. Yeah. So you can see that we have like 5 topics. In this second topic, these are the most occurring words. Similarly, in fifth, these are the most occurring words. And this is based on the intertopic distance map. So this fourth and first topic are like they have some overlapping words. So next we will view the topics. Okay, so the top, so these are the top 10 words in each topics. Like in topic 1, the network, security, paper, nodes. So it is something related to network analysis, or, and then topic 2 is about physics, change. Third is something like this. So it's still difficult. So let's visualize these topics with GG plot graph. I think because I'm using a different, let me show you over here. So this will be the results where you can easily see the proportion. These are the proportion of the topics, of the words in the topic. So in topic 1, you have this like network, which we have it's seen, right? So I think here I use only 5 words. So you can increase this to 10 or 15 or 10, 15 or 20. So you'll able to see. I think also there are too many topics, so it's like getting confusing. Okay, now it's better, I guess. Yeah. So like this 12th topic has research, sport, organ practice, And similarly there, so you get to know about like these are the main topics which are in your corpus. Next, we will talk about the probability distribution of words in the documents, and we will just see the representative documents for like topic 1. So it will give a better idea to label those topics. For example, in this, consists of the abstract for topic 1. And you will able to see like this is for like one, we can run it for like, maybe we want to know that more about like how to label, because it is very difficult to label the topic just with words. So we will just go through the documents, a representative document for topic 1, then topic 2, and it will help us to label it. Then we will save this as a CSV file, the top terms and then the top documents. And let me show you how it will look. Can you see my screen? Can you see the Excel
Yes,
file?
clearly.
This Excel file. Okay, so these are the topics, and you will. It's easy to like save it for your later analysis. So these are the topics and the words, and then it will also the doc topics is about, yeah. So it shows that the text 1 in our corpus is related to topic 12. Like this, it will now giving the value for each text. So in our corpus, there were around 2,879 abstracts. So so this was our data we used for analysis. So this for the text. So here we will able to get that. We can just copy it, and just for your visualization, let me show you. So here, so these are the topics. So this first document is in topic 12, and then you have to give label over here. Label, and then you have to see that what the topic 12 is about, and 9 is about, for instance, maybe it's about network. So you have to give labeling, and you can say that, okay, my first topic is in 12, and 12 topic is about network analysis or something. So whenever 12 is coming, we'll put that in the network thing, and you will, it is like easy for like this, you will get analysis. So this is how our first objective was, what are the topics we have analyzed this using LDA. Now second is how they are interrelated. For this, we will be using the second algorithm, that is correlated topic model. So let's start that. So we have already loaded the data and have the data feature metrics. So over here, we'll be using another library package, which is the quantitative text test, and we will now remove that words which were occurring earlier, like the can, use, uses, used, which we don't need in our corpus. So let's just run this. And then we again make our feature matrix, where we will use the corpus, remove the stop words in English, plus the our customized stop word, which we have seen earlier and was previous in our data set. And then again, we just did the same thing like earlier. Then we can again see the 50 words. Now you can see that it's now much cleaner, and there's no that word are coming like can, may. And you can again visualize this in the word cloud. So you can visualize this top occurring frequency words and big word cloud. Then we can now start with the correlated topic model. We will use the library STM, and first we convert the previous data frame into the STM one. Then earlier we used string function, but here we have other feature in STM where you can remove these sparse terms. So we will use that. Now here maybe we can also test by running 40 models. So because this is a little time expensive, I have already run this and saved it in a file. So if you have, you can so I'm like directly loading it. But if you want, you can just uncomment this and run it. Now we can explore the topics. So here you can see this topic. So the STM package will show you the topic like this. Here in the x-axis, you have the topic proportion, and you can see these are the main, like the topic 33 is occurring most in our corpus, which is related to students, education, technology, followed by person behavior, then computer interaction, visual, maybe it's about computer vision, and then so on. So next, so in STM, you have different visualization. Like first we have use the summary one over here. So you have others also like labels, perspective, and histogram, paste for histograms. So over here, let's try the label one. So for this, it will give you for a selected topic, it will let you know the top words used here. So like this, you can, if you want a visualization like this for all the topics, you can also have that. And then you can also change the weighing scheme. Like previously, we used DF, IDF. In STM packaging, there are different weighing scheme like FREX. So it's on your personal choice, on your data like analysis, what you want to do. So this is the example of using the FREX weighing scheme. Then you can also use lift. And you can know more about in the package detail. And packages, you go to STM, and then over here you can know more about the different weighing schemes and all other functions which are over here. And so there's no correct approach for that, and it's depends on you, like which weighing scheme you want to use. And now let's give topic proportion to our topics, and then now we can see that how they are interrelated, right? So because our main research question is like how these topics are interrelated, and this is the graph which shows that. So how this topic, like topic 31 and 34 is interrelated. So all we can say that most of the topics are too much interrelated. So, but this is not a very pretty visualization, so we can use another using the this network package. We will prepare the links and the notes, and with the topics we can see. So here, this is more interactive, and it's like more clear, and you can also move it and get to know, like, for example, this topic, which is on image feature
excuse
search.
me, Manika, can I say
Yes.
something?
Yes.
I think you set big, you say you show the result in another window, but you just share with us just our studio, I think, but so
Okay.
we can't see your result.
Oh, okay, okay. Let me try it.
Is it our studio or Jupyter? It's like Jupyter. Is it
No,
our
this
studio?
Yeah, it's our studio, yes.
Yes, thank you.
Can you see it now?
Wait, it's
yes. Is it? Yes, we can see it.
This screen, right?
yeah, yes.
Okay.
It's okay now.
So here, yeah, it is more interactive, and you can also see that clearly the topic that this is topic 10. It is related to topic your 16, and then it is related to main topic 27. Like this is more easy for visualization. So here we can see that how these topics are interrelated, and then we will use the term perspective is for how this topic 30 and topic 11 is interrelated, and the words which are occurring like most in both of them. You can see the word user is the most occurring word in both the topics. Similarly, we can use this for other topics which you are interested and want to know more about. Now, the next thing is the semantic coherence and exclusivity. So it is these are the two measures for topic interpretability, and the semantic coherence measures the consistency of the words used within the topic, where the larger values are better and mean the topic is more consistent. So and exclusivity is the distinctive the top words are to that topic. So you can see that this topic, so this is like exclusivity is on the y-axis and your semantic coherence on the x-axis. So you see that the word like the topic 4 is more coherent and exclusive, right? So like this, it just to again one of the metrics for your to show that how your topic are interpretable, and to give justice that you have done a good you have run the topic modeling properly. So now this is, so right now we have now seen that what are the topics in our corpus are, and also made a network graph and see how they are interrelated. Now last is to see like how the discipline, social science versus computing and the year, how they have effects on the topic. So this is our last part. So here also we have already loaded the data. So we will now create the corpus, where we will just use abstracts already we have. And now the additional thing is we're doing over here is having doc wars, which is in the field subject. We're selecting particular colleges, department that computing science and informatics, computing and the social science. So we can see that how the topics are varying in this subject field over the years. So next, again, we will have feature metrics, where again we have already did this, like we have our stop words, and then in our corpus we remove this stop words, remove the numbers, punctuation, and now we will do structural topic modeling with the subject and the year. So first we will load the package library STM. And then we will convert the data frame again to the STM package. And here, this is the additional thing we are doing here, where we're having doc wars with our corpus. And sorry, we already this again to remove this sparse words, we have done this. Now we are again using that 40 topics. This is just the repetition of what we have done earlier. And these are the topics we had. Right, so this is the topics. So again we will do topic proportion to each document, and now this is the main step where we are exploring the effects of the covariant subject on our data. So we will, for all the topics from 1 to 40, we will see how it's varying for subject and the year. So first we will just prepare the data, and now we will visualize it over here. So here we can see that the topics on the right are more likely to be on social sciences, and topic on the left are more likely to be on computing subject. And the topics in the middle are not significant, like they are neither in the social sciences nor in computing science. So this is very helpful for determining the topics. So we have already, like, even after topic modeling, we have also seen that in the department, in the colleges. So we can say that the colleges in the UNCC, which are in social sciences, are doing research more on these topics, and the college department in UNCC in computing are doing research more on these topics. So now we can also plot this depending on the ranking. So here we can see that so this is depending on the ranking. So this topic is ranked most and this is the least. So people are researching more on topic 35 in computing science department, and how this is now just goes down. So now we can see the effect of time, like how we have seen that how the topic is in, which are the main topic that people are researching in different departments. And now we can also see how it affects in the years. For example, I have compared topic 9 and 18 over the years. So we can see that over here, the topic 9 was, topic 18 and 9. And so topic 18 was researched more over the years than 9, and there's a decline in topic 9 in 2013. Like people are not researching anymore on it, but there was again a little bit interest in 2015. So like this, we can also compare the different topics over years, and I will invite you all to, you can do the similar for this, like have your exercise, like I have a different data sheet, and you can try this out. And let me know if you face any problem or have any, you are stuck somewhere or you didn't understand any step. So maybe if you want, you can try and do the similar thing from part 1 to 3, or maybe only one part you're interested to, and using this other data set.
This is now rendering the data set from GitHub. True?
Yes, yes.
Okay.
This is just a practice data set for you to practice, which I have just covered. Yeah. So you can try. So over there we have abstract. In this data set, we have title instead of abstract. So you can run the LD model and test out the different topics on the title field. Are you, is everybody trying this data set?
Yes, I'm trying to look at it. How about everyone?
So as shown earlier, you can go to this my GitHub repository the slides is over here, and this is the data set that I used and shown you today. If you go to code, this is the IMG file I used. You just go here and just go to code and download the zip file. You will get everything. Then if you go to code and do the IMG file, you can test it out on your own system.
Yes. Okay, thank you so much, everybody, the participants. Are you now downloading the code from Manika's GitHub? So we should do it now and asking you questions, or the presentation is ended.
Yeah, the presentation is over. It's just for your
Okay.
practice. If somebody has any problem and they can test it out, the code.
Okay.
Yeah.
Anyone wants to test the code now, or anyone have any question? Thank you so much for the great presentation. We should do it again, and for some questions. If anybody have questions, can we connect with you with the email?
Yeah, sure.
Yeah, okay.
Yeah, sure.
Thank you so much.
If you try it later and you have any problem, any clarification you need, like why I did it, so you can definitely mail me,
Okay.
and I will I will respond you back.
Thank you so much.